Hi guys, in this tutorial I'm going to solve question number 6, paper 42, November 2021. Particles P and Q have mass m and 2m. The particles are initially held at rest 6.4 apart on the same line of the greatest slope on our plane. We have a friction force. The inclined makes an angle alpha with the horizontal line. Sine alpha is given, so you can find the exact value of cosine alpha. Particle P is released from rest, so the initial velocity will be 0. And slides down, so direction of motion is down for the particle P. The first part, without complete reading, you have to show the components of the weight and the normal reaction and the direction of frictional force. This is for particle P. The frictional force will be up because the particle moved down. So it's better to show the components of the weight, which will be mg sine alpha and mg cosine alpha, normal reaction, and frictional force. What about particle Q? Simultaneously means at the same moment, particle Q is projected up. So for the particle Q, it's projected up. So direction of motion. By the same way, I have to show the components of the forces acting on Q. Particle move up, show the components of the weight will be mg sine alpha, mg cosine alpha. By looking at mass of Q, it's 2m, so don't forget to write 2m and normal reaction. Because the particle moving up, so direction of the frictional force now will be down. And also without complete reading, particle move down, so you can write equation of motion of particle P, particle Q moving up, you can find the acceleration. Say for particle P. For particle P, moving what? Moving down. So all the forces in direction of motion, which will be mg sine alpha minus frictional force is equal to ma. What else? R is equal to mg cosine alpha. What else? Frictional force is equal to mu r. By the same way, particle Q. Particle Q move up. So there is no force acting up, pushing force. So the particle move because of inertia up. So 0 minus 2 mg sine alpha minus frictional force equals ma, which is 2m times a. Don't forget the mass of this particle is 2m. And second equation, r is equal to mg cosine alpha. Third equation, frictional force is equal to mu r. So you can find the acceleration of each. Let's start now to read part A. Show the acceleration of Q. So we look at only the equation of Q. I will start from this equation. R is equal to m, G is 10, cosine alpha from sine alpha 0.8. If we try to draw the right angle triangle and show that the opposite 0.8 will be 4 over 5, 4, 5, 3. So cosine alpha will be 0.3, 0.6. By finding this value, so the answer will be 12m. Go to the second equation. Frictional force is equal to mu. It's given the coefficient of friction, 0.6 times r, which is 12m. So the answer will be 7.2m Newton. Back to the first equation. Negative 2m sine alpha which is 0.8, minus friction force 7.2 m is equal to 2ma. We can divide it all by m, then find the value of A. The value of A will be negative 2 times, forgot to write G, which is 10 here, negative 2 times 10 times 0.8 minus 7.2, then divided your answer by 2, so is negative 11.6 correct. By the same way, you can go to the particle P in case if I ask about the acceleration of particle A. By the same way, find R, which is mg cosine alpha, find the friction force, find the acceleration. Now look at part B. Find the time for which the particles are in motion before they collide. By showing the plane again, we have a particle Q move up and particle P move down. To get the time for where is Q and the P collide, you have to know first, they collide when the particle Q move up or when Q move up to the maximum height and the change direction of motion, they collide in the same direction or not. To know that, first try to get the maximum height when V is equal to 0. Now we'll talk about particle Q. Particle Q starts from initial velocity 10. It's written here. Particle 10. And V equals 0, acceleration found negative 11.6. By using V equals U plus AT, so 0 equals 10 plus negative 11.6 times T. You can find the value of T. T is 10 divided by 11.6. So the answer will be 0.862. Also find the distance covered by the particle Q. S equals UT plus half of AT squared. So S equals initial velocity, which is 10, time found 0.862 plus half of the acceleration, which is negative 11.6 times 0.862 squared. 10 times 0.862 plus half times negative 11.6 times 0.862 squared. So the answer S is equal 4.31. So the distance covered by the particle Q when it is moving up is 4.31. We'll try now to get the displacement covered by particle P. So I need to calculate the acceleration. So I will go for this part again. We'll start with the normal reaction. M times 10 times cosine alpha, which is 0.6. So the answer will be 6m. Go to the frictional force, mu is 0.6 times 6m. So the answer will be 3.6m. Go to this equation. Friction force is 3.6m, mg sine alpha, m times 10 times 0.6 minus 3.6 is equal to ma. We divided all by m. So the answer will be 6 minus 3.6 is equal mass is m, g is 10, sine alpha it's 0.8, sorry. So 10 times 0.8 minus 3.6. So the answer is 4.4. Acceleration is 4.4. Now we'll find the distance covered by particle P moving down. P for the particle P. S is equal ut plus half of at squared. So S equals initial velocity start from rest, half acceleration just found 4.4, and the time is, we found it here. Sorry, I will write this part down. For particle P, S equals ut plus half of at squared. The initial velocity is 0, have acceleration 4.4, and the time 0.862 squared. Have times 4.4 times 0.862 squared is equal 1.634. And now this distance is 1.634. So still there is a part in between. You can find this value. It's 6.4 minus the sum of each, 1.634 and 4.31. 6.4 minus 1.634 and 4.31. So the answer is 0.456. This means now particle Q will start to move down, slide down, and particle P now is also moving down, and there is a part in between, 0.456. Now I will show the direction of the two particles. Now we have a particle Q move in this direction and particle P move in this direction, and there is a part in between, 0.456. This means they collide when the particle Q move down and the particle Q move down. Let's say they collide at this point. So the displacement covered by P minus displacement covered by Q is equal to this value. Now, S of P minus S of Q is equal 0.456. SP UT plus half of AT squared. This information for P, and UT plus half of AT squared, this information for Q, is equal to 0.456. Now for particle Q, for particle P, UT, I will try now to get the initial velocity, which is final velocity for the first trip, which will be V equals U plus AT. So V is, U is 0, A is 4.4, and the time 0.862. 0.862. I use it as initial velocity. So 4.4 multiplied by 0.862 is equal 3.7928. The initial velocity now is 3.7928. t plus half of a, which is 4.4, and t squared minus ut is now 0. We'll get the acceleration of the particle q will be same 4.4. You can calculate it again if the particle move down. So mg sine theta minus friction force is equal to ma. You will get it same, half 4.4 times t squared is equal to 0.456. Positive, negative cancel, so you can find the value of t. 0.456 divided by 3.79, you will get 0.12. So the total time will add 0.862 plus 0.12. So the time will be plus 0.862. So the final answer will be 0.982. This is the time taken before collide during motion. Part C, the particles coalesce on impact. Find the speed of the combined particles immediately after the impact. Now, we'll start from part B first. Particle P and particle Q, after collide at this point P, we'll find first the final velocity for this part. Find the final velocity of Q and the final velocity of P at the of Q and velocity of P. V equals U plus AT. For the particle Q, after reach the maximum height and start with initial velocity 0, acceleration is 4.4, and the time found is 0.12. So 4.4 times 0.12, so velocity 28. Now, velocity of P. Velocity of P, U plus AT. Initial velocity found in the previous part, which is, I think it was 3 point, the velocity, which is V. Want it again? Yes, yes, this velocity, 3.79, 3.79, 3.79 plus acceleration 4.4, and the time is 0.12. 3.79 plus 4.4 times 0.12. So the answer is for velocity of P, 4.318. 4.318. This is the velocity before the collision. Now, M1 U1 plus M2 U2 is equal. Both now are one particle, so move with the same speed. So I will write here V and V. For M1, it's 2mv plus 2mv, so you can add 3mv. This is the right side. For the left side, this is 4q, and this is 2m, and velocity before the collision is 0.528, 0.528, plus mass of the particle P is m, and the velocity is 4.318. We can add and divide it by m. We can divide it by m. So 2 times 0.528 plus 4.318, then divided the answer by 3. Divided the answer by 3, so V equals 1.79. This is the final answer for the velocities after the impact.